Hello everyone, here is a question from electrochemistry. Given the equilibrium constant Kc of the reaction is 10 times 10 to the power 15, calculate the E cell standard of this reaction at 298 K. The term that we use in the Nernst equation at 298 K is given as 0.059 volt. We know that Nernst equation is E cell is equal to E cell standard minus 2.303 RT by NF log Q. Q is the reaction quotient. We also know that at the equilibrium Kc is equal to Q. Also at the equilibrium delta G is equal to 0. This means E cell is equal to 0, isn't it? Because there is no net electron flow. Therefore, the cell potential is 0. This means E cell standard is equal to 2.303 RT by NF log Q. Here, copper is becoming copper 2 plus. That means oxidation. Ag plus is becoming Ag. That means reduction. Therefore, at the anode, because whatever be the cell, it is always anodic oxidation and cathodic reduction. At the anode, copper solid is losing 2 electrons and becoming copper 2 plus. At the cathode, reduction is happening. Ag plus gains an electron and becoming Ag solid. But to balance the equation, we have to multiply this entire equation by 2. So therefore, the net reaction is copper solid plus 2 Ag plus giving copper 2 plus 2 Ag. Therefore, the quotient here is concentration of copper 2 plus divided by concentration of Ag plus whole square, because we have the stoichiometric coefficient 2 here. We don't write solids in the reaction quotient equation because they are constant. Now, this term is given as 10 to the power 16. Therefore, E cell standard is equal to 0.059 divided by 2, because 2 moles of electrons, times log 10 to the power 16. So therefore 16 we can bring it here. This means 0.059 divided by 2 times 16, because log 10 base 10 is 1. So therefore this is 8 times. This means 0.059 times 8. 59 times 8 would be 8 times 9, 72, remaining 7. 8 times 5, 40, so 47. So therefore this will be 0.472 volts. The E cell standard value is. This means option 3 is correct. The closest value that we can see is this one. So therefore option 3 is correct.